All right, so let me go through the solutions here for number 6. So I'm going to come over to my table here that's already formed. So what we needed to do was first write out the known and the unknown. Do this over here. This time we were starting with 21.9 grams of O2. And the unknown this time was grams of aluminum oxide. Again, I just got that from the problem. We had final mass was 21.9 grams of O2. How many grams of aluminum oxide did the reaction begin with? Okay, so I'm going to have G for grams. I got my table all set up here, so I just rewrote my balanced chemical reaction one more time. G for grams, MM for molar mass, moles, change, and X. Remember, the two that I always know, always know, are molar mass and change. So if I figure out what they told me I'm starting with 21.9 grams of oxygen. I'm trying to figure out the grams of aluminum oxide. So I'm going to go ahead and fill in what I know for those two because I'm going to need them the bare minimum. So my change, remember, is my coefficient, which is 2. Go ahead and put aluminums even though we're not going to need it. 3 for oxygen. Now my molar masses, we already found aluminum oxide, which again is going to be 2 ALs plus 3 O3s, so it should be 101.96. My molar mass for oxygen is 32.00. Oxygen again is 16 times 2 because the subscript is a 2. Okay, and now I start with what they gave me. So I take 21.9, I'm going to divide it by 32, I'm going to get 0.68437. I take that number, I divide it by 3, I get 0.22812. Take it right over here. This becomes now my X. Remember, I divided going down the chart. This becomes my X over here, so it's going to be 0.22812. I'm now going back up the chart, so I'm going to multiply. So 0.22812 times 2. I'm going to get me to 0.45625. Take that and multiply it by 101.96, which is my molar mass. 3 significant figures in my data, 3 significant figures in my answer. It's going to be 46.5 grams of aluminum oxide. Okay, and you have to label them. Okay, so now just as a recap, what do you have to have done? And again, for those of you who want to do dimensional analysis, I can work with you. Chances are you're good at the math, and I'll help you figure it out. But requirements, you still have to write down the known and the unknown. That doesn't change. Either the chart or dimensional analysis, everything labeled, and you have to make sure to circle your answer with the correct units and correct sig figs. So that has not changed. Now, we're going to do one more problem together. We're going to do part 1 up here. You guys don't have this one written down because it's just extra practice, but this is another way that you see the reaction where you'll notice this one just tells me hydrogen gas reacts with nitrogen gas to form ammonia. How many grams of ammonia can be formed from 1.5 times 10 to the 4th milligrams? Okay, well, the thing is you have to write the reaction first. So let's come over here to another chart. Oops. All right, so there we go. All right, so if we look at what they told us, okay, they told us that I had hydrogen gas. Hydrogen gas was going to react with nitrogen gas, both part of Hunkel Fibber, so they're H2 and N2s. You should be writing this down as well. This is also going to be evidence that you watch the notes, so make sure that this is written down in your journals or on a sheet of paper with your other problems. So we've got hydrogen gas plus nitrogen gas is going to give us ammonia. Now remember, ammonia was one of those different ones that we had to name. The formula is NH3. Now to get this balanced, the hydrogens are a little tricky. I got to put a 2 in front of the ammonia, which is going to give me 6 hydrogens over here. 3 in front of the hydrogen will give me 6 hydrogens, and then my nitrogen is already balanced. Now, what did they tell me? Okay, they told me, back here, I had 1.5 times 10 to the 4th milligrams. Okay, so 1.5 times 10 to the 4th milligrams of hydrogen. The unknown, they wanted to know the grams of ammonia. Okay, now if I fill in my chart here, I've got grams, molar mass, moles, change, and X, but I don't have a milligram. So the first thing that I have to do before I can go any further is first I have to go from milligrams to grams. Okay, and in 1.5 times 10 to the fourth milligrams, in 1 gram there are 1,000 milligrams. Okay, remember I told you those metric prefixes. So we do the metric prefixes either at the beginning, if they give it to me that way, or if it had asked for me in milligrams, I would do that at the end. So if I take 1.5 times 10 to the fourth, divide it by 1,000, I get 15 grams of hydrogen to start with. So I'm going to go ahead and put my 15 grams up here. What I'm looking for is my grams of ammonia. So, what do I know? Well, the other stuff that I know is I also know the molar masses and I know the changes. So I can go ahead and put those in. My molar mass of hydrogen, remember I only worry about the formula itself, so just the subscripts. So hydrogen is 1.01. There are 2 of them, so it gets me to 2.02. That's a 1, bad one. So my molar mass of hydrogen is 2.02. I can also fill in the change of hydrogen because that's just the coefficient. I can go right across and do that. There's 1 nitrogen, even though I don't need anything with nitrogen, and there's 2 ammonias. Now I'm going to have to go all the way from grams of hydrogen all the way back up to grams of ammonia. So what I'm going to need is I'm also going to need the molar mass of ammonia. So I might as well do that ahead of time. So if I go to the periodic table, I'm going to keep the color scheme. I want 1 nitrogen, which is 14.01. I also want 3 hydrogens, which is at 1.01. That's going to give me a total of 17.04 grams per mole, and that's going to go right here, 17.04. Now I have all my conversion factors filled in. Now I can do my math. So I'm going to start right here with what I was given, the data that I was given. I'm going to go down the chart, I'm going to divide. 15 divided by 2.02 is going to be 7.426. 7.426 divided by 3, 2.475. I'm carrying extra significant figures here because it's going to ensure I get the right answer. Best way is to just leave this on your calculator. Take my 2.475, bring it over here. So I've got 2.475. Remember, I'm now going up the chart, so I'm going to multiply. So I take 2.475 times 2, 4.950. Take 4.950 times 17.04. I only had 2 sig figures at the beginning, so I can only have 2 sig figs, so 84 grams of ammonia. Okay? Alright, now we've got one more here. This time we've got magnesium chloride decomposes into magnesium and chlorine. How many moles of magnesium will be produced by 8.45 grams of magnesium chloride? Okay, well first we got to write a balanced chemical reaction. So what they told me is I started with magnesium chloride. Now magnesium is a 2+, chloride is a 1-. So my formula for magnesium chloride is MgCl2. It's going to decompose into magnesium, which is plain old Mg, as well as chloride, which is part of Hunkel fiber. So it's already balanced just the way it is. I'm going to go ahead and set up my chart, grams, molar mass, moles, change, and X. And if I come back over here, what did they tell me? Well, we want to know moles of magnesium from 8.45 grams of magnesium chloride. Okay, so let's jot that down over here. My known was 8.45 grams of magnesium chloride. Okay, and we want to know moles of magnesium. Okay. Whoa, a little out of whack there. There we go. Alright, so I've got 8.45 here. And as far as I have to go is just moles of magnesium. Right here. That's it. Okay, it's not asking me anything about chlorine. It's not even asking me about the grams. I just have to go as far as moles, so it's going to be a little bit less work. So what can I fill in? Well, I can fill in all the changes that are all ones. 1, 1, 1. So that's going to make the math a lot easier down here. Now the other thing that I'm going to need is I'm also going to need to know the molar mass of magnesium chloride. So I'm going to take 1 magnesium and 2 chlorines. Okay, magnesium is going to be 24.31 if you find it on the periodic table. Each chlorine is going to be 35.45. We need 2 of them. Add that all up, we get 95.21 for our grams of chlorine. And now we're ready to start. So we're going to start at 8.45. We're going to divide going down the chart. We're going to take it over here. We're going to multiply coming back up. So I take 8.45 divided by 95.21. I get 0.08875. Now you don't even have to be really great at math to figure out that it's just going to all be ones. So let's say we then had divide that by 1. It's going to be 0.08875. We carry this over, 0.08875. Now we only want 3 significant figures in our answer, so this is going to round up to 0.0888, and it's going to be moles of magnesium. Okay, and that's it, 3 sig figs. Now if it asked us for grams of chlorine, we could take this right over here and carry it up this way as well. But hopefully that helps. You've got some practice problems, work on those, and we will go over them when I get back. Okay.